Today we are doing Unit 6, and we have our vocabulary words is mean, median, mode, range, the definition from the median, and the mean. And so, mean means the average of the number data that is set to denote by X, which is read X bar from the data. X1, X2 dot, and Xn means that M, the mean is X equals X1 plus X2 plus etc. Then divided by the numbers that's total that's added up. The median is the number data that is in the median is this number that is the middle number when the value is written in number order. If the data has even numbers of value, the median is the mean of the two middle numbers. And mode, the mode of the data is of the data set is the value that occurs most frequently. There may be no mode. There may be one mode, no mode, more than one mode. Then the range, number data set gives the length of the current data. It is the difference between the greatest value and the lowest value of the number data. And from the mean is the difference of the data value and the mean of the it's the difference of the data value and the mean of the data set and the absolute value and the mean the number of data set is the value of the data from the mean. So that means x1 minus x plus x2 minus x plus x3 minus x, then divided by the number. Like right here, is the mean, because right here is 65 plus 68 plus 71 plus 77 plus 70 is plus 81 plus 82 plus 86 plus 88 plus 93 plus 93 plus 95 plus 96 divided by 12 gives you 996 divided by 12, and it'd be 83. And the median is the mean, of two middle number. Average is 84. The mode is 93. The mean and the mode best represents the data. The mode is the scientific greater than most of the data. Then we have a quotile. A quotile is the median of an ordered data set. The mean of the upper half of an ordered data set called the upper quartile, or the mean of the lower half of an ordered data set called the lower quartile. And we have the inner quartile range of a data set is the difference between the up quartile and the lower quartile. And we have an example. The baseball The data set below gives the number of home runs by each player on the Bears and Wildcats during the season of baseball league. Comparing the data using the mean, median range, and interquartile range. So the Bears 28, 25, 21, 19, 18, 14, 10, 8, 7, 5, 3, 2. And the Wildcats 20, 19, 18, 16, 15, 15, 12, 11, 8. 11, 9, 8, 6, 5, 4. And the Bears X equals 28 plus 25 plus 21 plus 19 plus 18 plus 14 plus 10 plus 8 plus 7 plus 5 plus 3 plus 2 divided by 12. That'll be, add all these numbers up at the top, be 160. Divide that by 2, that'll be 13.3. Then the median is 14 plus 10. Divide that by 2, that'll be 24 over 2 equals 12. And the range would be 28 minus 2, that would be 6. And the lower quartile would be 7 plus 5 divided that by 2, that would be 12 over 2 equals 6. And the upper quartile would be 21 plus 19 divided by 2, that would be 14 over 2 equals 20. And the interquartile range would be 20 minus 6 equals 14. Then on the Wildcats, it will be X 20 plus 19 plus 18 plus 16 plus 15 plus 15 plus 12 plus 11 plus 9 plus 8 plus 6 plus 5 plus 4. Divide that by 13. At the top numbers, you'll get 158. Divide that by 13, it'll be 12.2. And the mean is 12. And the range is 20 minus 4 equals 16. And the lower quartile will be 8 plus 6 divided by 2. That'll be 14 over 2 equals 7. And the upper quartile range, that'll be 18 plus 16 divided by 2 equals 34 over 2 equals 17. And the inner quartile range will be 17 minus 7 equals 10. And they'll be in the quartile. And the Bears mean is greater than the Wildcats mean. So the Bears average more home runs per player than the Wildcats. The Wildcats range is less than the Bear range, so their data is less spread out than the Bears data. The Wildcats interquartile range is less than the Bears interquartile range, so the Wildcats middle 50% of the data shown less than the middle 50% of the Bears range. And it classifies as today. I'm going to show you some more examples. Like for right here, number 1, find the mean, the median, the mode of the data. So we do something like this. So there'll be 6, 1, 3, 8, 5, 11, 1, and 5. So 6 plus 1 plus 3 plus 8 plus 5 plus 11 plus 1 plus 5. And the total of that will be 6 plus 1 is 7, 7 plus 3 is 10, 10 plus 8 is 18. Then 18 plus 5 is 23. 23 plus 1 is 24. That would be 25. And 25 plus 5 is 30. So drop the 2, carry the 3. So 3 plus 1, that will be 40. So we come up here, divide 40 by how many numbers you have, and we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers. Divide that by 8. They'll be equals to 5. So the mean will be 5, and the median will be, we gotta put these in order now. So it'll be 1, 1, 3, 5, 6, 8, 11. And so count, be like, cross them out one by one. And so the mean is 5. And we just gotta check for the mode. And since we have more than one number as the mode, we could go back and look what the mode is for. It says the mode of the data set is the value that occurs most frequently. There may be one mode, no mode, or more than one mode. So the mode will be of number 1. It'll be 1. I say 1 and 5, cause 1 and 5 they occur the most in this right here, in this particular one right here. And we can do another one, or we can do the one about that one right here. We can do one of those. The absolute, the mean, find the range and the mean of them. We can do number 9. And how we do that, we gonna do number 9. We gonna number 9. And the numbers are 10, 7, 13, 10, and 8. So we put them in order. And it says, for this one, it says round to the nearest hundredths if necessary. So if we have a decimal to the nearest hundred, or in the thousands, and we have to round it to the nearest hundredth beside it, so we can get our actual number for number 9 if we have a decimal. So we're gonna put these in order right here. So it's gonna be 7, 8, 10, 10, 13. So 7 plus 8 plus 10 plus 10 plus 13. 10 plus 10 is 20. It's 20. And 20 plus 13 is 33. Then 33 plus 7, that'll be 40. And 40 plus 8, that'll be 48. So it'll be 48. Divide that by 1, 2. 48 divided by 5. So 48 divided by 5. Take 5. So we see what can go in 48. 5 times 9 is 45, so 945, that'll be 3 decimal, bring down to 0, there'll be 6, so it'll be 9.6, so we add these numbers right here to this number, so we do 7 minus 9.6 and 8 minus 9.6. We do 10 minus 9.6 and do another 10 minus 9.6. We do 13 minus 9.6, so 7 minus 9.6, so we can't do that. There'll be 8, there'll be 16, so there'll be 9.8 negative 8.9. Since 7 is lower than 9.6, it's negative. Then it'll be the 8 minus 9.6 is so that would be 8 minus 9, that would be negative 8.8. And 10 minus 9, 10 minus 9, that'd be 1.6. This 10 minus 9.6 would be 1.6. It goes for the same for 10 for the other one. And 13 minus 9.6, that'd be 6 point, take 0, that'd be 13. So that'd be 4.6, that'd be 4.6. Then add all these up, but turn this into a positive right here and add them all up and divide them by how many numbers they are. So that would be 8.9 plus 8 plus 1.6 plus 1.6 plus 4.6, so 17, 23, 29, maybe 35. Then 5, 6, 9, 17, 25 decimal, then 25 divided by 1, 2, 3, 4, 5 divided by 5, so that would be 5. It goes in there 5 times, so that's 25. Cross that out because that's 0. Then bring down to 5. Minus 5, there'll be 1 decimal, so there'll be 1, 5. Cross that out, 0, 0. So our answer is 5-1. And today, that is your unit 6. That is your unit 6 for today. Have a nice day. Bye.